Join the top portion.
Huh? Huh?
Cannot lah.
It's just asking you. Do you have a tripod?
I have a tripod.
Okay, yeah, I'll be doing that, right?
Yeah.
I dropped something else.
When the gaseous nitrogen is liquefied into a liquid, we call it the liquefaction point. Okay, and then when it goes from liquid to a gas is your boiling point. So the boiling point of liquid nitrogen is minus 196 degrees Celsius. And if I were to put this into a room temperature beaker, immediately it boils, right? And you see it is a colorless liquid. You see it's a colorless liquid like this. Yeah. Of course what you see is not nitrogen, it's actually condensed water vapor, because our humidity in Singapore is easily 60%, even in aircon room. And you see that it immediately boils. It's pretty cold.
Oh my god!
It bites you.
Ouch! Yeah, it's
It bites you.
Jacob.
No
longer.
teeth.
Okay. Ow! Ow!
Yeah, it actually bites you. Wait a little bit longer. Yeah, it does bite you.
Try. I don't want.
Okay.
The cameraman never tried.
Cameraman didn't try. Okay.
Why can't I touch it?
Yeah. Does it bite you? If you put it longer, you will bite.
It's not biting me. Okay, yeah, it's biting me. Let's get on.
Okay. Now,
Oh, it's a balloon.
you will. This is a balloon.
Wow!
Balloon.
Green PR balloons.
Hey, Fiona.
That was
Okay,
10
never mind.
years ago. We printed for our anniversary PR balloon. And of course, the website is very different now. So we are going to put this over the PR balloon, and let's see the balloon. As the air inside the balloon shrinks, the balloon also shrinks. Oh dear. So can you see the balloon?
Why do you shrink?
Why does it shrink? Good question.
The air contract.
The air contracts, yeah. The air inside contracts. And when the air inside contracts, it's still painful.
Okay, I think I'll take it hard.
Yeah. So now it becomes flexible again.
Did it become smaller?
Does it become smaller? Maybe yes, maybe no. If it warms up to the same temperature.
Can you taste those balloons?
Alright, let's try this kind of balloon.
Oh, that's color. Is it twistable?
This one no PL.
Is it twistable?
Yeah.
Obviously.
This is the one it is.
Okay, make one more. Nice color!
Purple color. Wow. Okay.
Let's make a parrot.
Make a crown for the head. You know how to make?
I mean not make a parrot, but I don't know how to make the
parrot.
thing.
So simple.
Oh, okay.
I used to go for a
Anyway.
class, but everything.
Yeah.
I don't make a sword.
Oh, I can make a flower.
Yeah. I know how to make.
Oh my god.
Oh, okay. Take a shot. Okay lah. Never mind. So let's try that. again.
No, everything is.
Yeah.
It's scary. I hate balloons.
Why?
It's very loud.
Yeah.
Yeah. Okay. So what we do is we want to again pour liquid nitrogen over this, so let's not blow it up. Yeah. And then we turn it here, and then we turn it here. Okay. And then we put liquid nitrogen over this again.
What's this?
Now,
supposed
liquid
to be?
nitrogen has to be kept in a Dewar flask. The word Dewar, D-E-W-A-R, Dewar flask, is a vacuum flask. There's actually a vacuum that's between two layers of glass, and that will prevent heat loss or heat gain from the surrounding by conduction and by
The flask says Gloria.
convection, but it cannot prevent heat gain by radiation. So let's put this now, and then you'll find that anything that is flexible will become alright, okay, let's look at this. This one
Not
is
long
not
enough.
so long, not long enough.
Looks like the Chinese sausage.
Yeah, it actually,
It looks like red date.
yeah, it looks,
Chinese.
actually it looks, let's take this one. This one is, now 5 years ago when I started playing with this liquid nitrogen, I was actually very scared, like most people. Then they begin to wear gloves. Actually, there is no need to wear gloves. But now this is as stiff as anything, then I'm going to crack it.
What's that?
Balloon.
It's a balloon. It was a
It was a
flexible balloon. And now the flexible balloon has gone to shreds because it was stiff. Actually, rubber molecules are actually macromolecules. They're very long, and once it freezes, it vibrates much less, so it becomes stiffer, and you can crush it like this. Okay. That's what happens when you have very cold liquid nitrogen. Very cold liquid nitrogen is used in the branch of physics known as, now it thaws again. It thaws again and becomes flexible. And it is used in the branch of physics called cryogenics, and is also used by NUH sperm bank, where you want to freeze the sperm. Then it's put in liquid nitrogen, and then after that you want to use it for in vitro fertilization or test tube babies. Then they got to pour that. Okay? So now, cryogenics.
Yeah, all you do is just freeze the person. You can't even revive them or anything. What's the point?
You can, but you have to change your blood if you are going to revive a person. So what we're going to do now, we are going to pour liquid nitrogen onto your hand.
Yeah.
Oh, okay.
No,
thank you. No, thank you, no, thank you.
Why?
No, that must be Chinese.
No,
Yeah, it's okay, it's
You
okay.
first, you first.
No,
Come on, before you.
How are you?
It's okay, it's okay, it's okay.
Until I splash on you.
No,
One.
Charlie
Alright, try on me.
Yeah.
To tell you that actually it is actually okay to pour.
Yeah.
The very moment I pour it on, you turn it over. It's okay, it's fine.
Does it bite? Does it bite?
It doesn't bite.
Here we go.
Okay, when I pour it on, you turn it over. You feel nothing, right? No, if you felt nothing. Or
Okay, I'll
maybe
try.
he's lying.
Oh no! Okay, I'll try.
I try.
No, but don't hold my hand.
Okay, I got you.
Okay, you don't hold my hand, okay? I promise I'll take
Liquid
it.
nitrogen danger also.
Supposedly.
I
hold you.
Okay.
You
Okay.
actually behave a little bit like Gloria.
Okay. Yeah.
You're making it hard for the
I
kid.
don't.
No,
Okay.
I turn it over for you. I turn
Okay,
it over for you. Okay, when I say turn over, you turn over. okay. It's okay. Yeah, you would not feel.
I turn it over myself.
You not feel. Yeah. So they asked. One of them asked yesterday, "What happened if we don't turn it over?"
right.
I said, "Do you want to try?"
You put for too long, your tongue will drop off, right?
No lah. We don't want to dip it inside. So can you see? Yeah. But if it goes onto your skirt or onto your pants, it might bite you a little bit. Let's splash on him. It bite you, Does it bite you a little bit? Not at all. Okay, come in.
Don't spray us! What?
Okay, come. Hey, chicken.
No, does it bite you if you do this?
There's a bone, right?
No, you must.
Oh, it's you know, you vibrate.
Okay. Anyway,
Hold it. You get one big holder.
Really?
what is this?
A kettle.
No, more than a kettle.
Thermos kettle.
No,
A special pressure cooker.
a special kettle. Yeah, it's called starting with W.
Water kettle. Wild kettle.
It is called a.
The door.
Okay,
Alright. It's called a. You don't know what is this called?
Wave kettle. Warped kettle.
a wood kettle.
Shut up.
Water kettle.
Red kettle.
Wet
Warm
kettle.
kettle. White kettle. Wet
Wonder kettle.
A warped kettle.
It's called a whistling kettle.
Oh yeah!
Oh,
Oh
nice.
yeah.
Oh yeah, this is right.
It's in the, you know the
Yeah,
Three
I
Teddy
heard
Bears, the
this
cartoon?
No, no, we don't watch Three Teddy Bears cartoon.
No, when you're young you don't watch it.
No.
No.
Yeah, deprived childhood.
We watched Dora.
Stop.
Dora wasn't there when we were young.
Stop recording.
Stop. Let's put this inside. Yeah.
We're not aiming for police or Jessica. No, it's spraying out.
Okay, let's put it inside here. And let's see whether it whistles or not. And it's spoiled already. Oh, this whistling is spoiled.
Never going out there.
Yeah, the whistling is spoiled. Anyway, it's supposed to whistle, but it is not whistling. But what is coming out is cold.
Okay.
What is coming out is pretty cold. And what you see here is actually very dry ice that will not melt as fast. Anyway, I spot the whistling kettle. Actually, I forgot that I don't take it out from here. I should just open here and put it in. But never mind, there's still a little bit more.
Scary.
Yeah.
Did anything come out?
No.
Oh, no.
No, nothing came out.
But I heard something.
It's a dangerous place.
Now, the guy who actually filmed snowflakes was done in Vermont. He went into the winter air, and then he took his microscope and used this to film snowflakes. Right? And I don't know whether we can film snowflakes from here, because I recently discovered a digital microscope where you put on it and it can be fed onto your computer. So I probably have to buy that digital microscope. And this is very dry frost.
Yeah, okay, I believe you.
Keep on munching, okay?
What if I laugh with my mouth open?
No, don't laugh.
I will laugh
Try
at
not to
how.
laugh. Try not to laugh. Okay. Munch. Bite. Munch. Keep on munching. Keep on munching. Some more. Some more. Some more. Yeah. Okay. One more time.
Why?
No. Yeah. Huh?
Nothing
One more
wrong.
time. Okay. You want to take a drink?
What?
Yeah. Yeah. Take a drink. Finish.
I feel very no privacy. Okay.
Okay. Bite, huh? And then close your mouth. Keep on biting. Bite harder. Bite harder. Okay, that's good. That's good. After we'll see you on the video and see what you look like. Okay. Now you have the
No
chance.
privacy.
Now you have the chance to see what they will look like. They didn't want to smile. They didn't want to laugh. Okay. Now your turn. Sophie.
Your turn.
Sophie, your turn.
Ask
my
me your
turn.
turn.
Yeah, your turn.
You mean how you take? No.
Can you dip one more?
Wait, what was that?
Yeah.
What was I supposed to do? Bite the cracker?
Yeah, bye.
Can you put your hand?
Yeah. So can we take video? The phone, ah?
No, no.
And then how we
can
can do?
20 seconds.
Then
Just
you-
take it out.
then, okay, now you look at Sophie how
You want me to video it? Cannot watch the video.
That's
Video.
fine, okay.
I don't put it in
Zoom.
my mouth.
I put it in your mouth. Like that, yeah. And then you munch without opening your mouth, okay? Munch. Yeah. Now munch more. Okay. You want to take a drink first? Take a drink first. Take a drink.
Sure, what's your...
Yeah. It's good to wet your mouth. The more moist it is, the greater will be the effect.
Yeah, thanks all.
And then that's what you look like.
No, that's a good expression.
Okay. That's what you look like. Okay, bye again. Right.
Oh, shit.
She's turning the dragon like that. Alright.
Alright.
Yeah. So now, next Kona, your turn. Then you can have it. Hold the pot. Kona, your turn. Come on.
You have video or picture? No, no, no.
Yeah.
My tongue is pain.
Yeah, you must keep on biting. You must keep on biting. That's
Nothing.
why you
No laugh. That's no laugh.
keep on biting. And then maybe this time we'll
Your tongue is pain,
we'll
No
go
lah,
one step
no
further.
lah.
The second time you bite, you press one of your nose.
I know. Come on, finish.
Okay. Keep on biting. Keep on biting. Close your mouth and keep on biting. Yeah. Okay. You have to need a drink. Okay. You want to take a drink? Yeah. Keep on biting.
Close your nostril.
Close one. Hey, forgot to close the nose. Close one nose. Close one.
No! Wait.
Never mind. Close one
I just do
nose.
that.
Yeah, close one nostril. Close that one.
Like
Close
that.
your right one. Close your
Like
right.
that.
Close your right. Close your right.
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 No, I don't even tell it.
Right. Right. Now your turn. Yeah. Have you tasted it before? Not yet, right?
Did you take mine?
Actually,
I don't know, ask her now.
actually,
Mine.
you have liquid cooled ice cream. It is very expensive to make because getting all this nitrogen takes a lot of effort. Okay, then you bite without opening your mouth. Okay, bite. Without opening your mouth, don't open your mouth. Yeah, that's better. Yeah.
Yeah, dry your gold block nose. It's only come from one nose.
Yeah. Don't open your mouth. Don't open your mouth. Keep on biting.
You can use this as a medicinal way to find out whether one has runny nose.
Yeah, that's right. That's better. Can you see yourself? Okay, looks like a dragon. Okay.
Are you gonna eat?
Try ah.
Yeah, you videotape him. Yeah, you videotape him. Keep on, keep it running, keep it running, keep it running. Keep it running. Okay.
That's like a lot.
Yeah.
Okay.
Keep it running, and
It's so cold, I guess.
How to zoom ah?
That's so much, right?
yeah,
Yeah,
REC is there already.
Yeah,
right?
zoom in.
Yeah, REC is there. So you can zoom it onto his nostril. Keep on biting. Keep on biting.
Wow.
Wow,
Best effect.
that's a big dragon. Yeah. Oh, that's a lot. I think his mouth is very moist. That's one. Okay. Right, stop. Thank
Oh,
you.
stop.
Yeah. Press again the red knob. Okay. So this is a ping pong ball, and I punctured 2 holes. Here one and here another one, and I punctured it diagonally at a glancing angle. Not this way, but this way, and then this one I punctured this way, so that when I dip inside liquid nitrogen, the air inside the ping pong ball is going to cool right now. When it cools, it contracts. When it contracts, according to Boyle's law, the pressure inside here will be less than atmospheric pressure, and then atmospheric pressure will force liquid nitrogen inside the ping pong ball. Okay?
No idea what you just said.
So let's say we have this.
No
now.
idea what you just said.
Never mind. After I explain all to you. So we put this inside. We dip this inside, and then we dip this inside.
We spoil marker.
No. Don't spoil the marker. So once the ping pong ball has enough liquid nitrogen inside it, we will take it out, and let's see how it's going to behave when we take this one out. We'll take this ping pong ball. Alright. When you see this ping pong ball will spin this way. Wow! That's pretty fast, isn't it? When I put this on YouTube about a year ago, they were wiring all over the place, and about 500,000 people would have viewed this now. Over 400,000 people. Yesterday, Tabitha was saying that maybe a lot of people, same people, lock in to see. Maybe he said only about 15 people, so 15 people. Just imagine you got to lock in. Yeah, basically what is actually happening is the gas vaporized, and there will be 2 streams of nitrogen, one coming out this way, another coming out that way, and that creates a turning effect about this axis, right? So it creates a thought, a moment, a couple of forces this way and that way, and when it goes like this, it will then turn about this axis, and it's actually the turning effect of this, and it's actually Newton's third law as well, because as the liquid nitrogen oozes out, this portion will go forward, right? And that is basically how a rocket is being fired into the atmosphere, where the hot air comes out. Now the hot air comes from the combustion of liquid hydrogen and liquid oxygen. You got to use liquid because liquid occupies the smallest space apart from solid. Smallest space within the 2 tanks. They couldn't even use compressed hydrogen and oxygen. That's not enough. That's not enough. So the liquid oxygen and liquid nitrogen, liquid oxygen is LOX for short, pumped in at the very last moment, probably about 2 or 3 hours before liftoff, right? Because it's very cold, and you need that. Okay, so there you are. We'll take a short break and prepare to make lollipops. All right. room temperature right now. This is a room temperature of about 26, 27 degrees compared to minus 196. It is actually very cold. If you look at this portion, look at this worksheet that we are supposed to fill in. Gaseous nitrogen turns into a liquid at minus L for liquid. Fill it up. Turns into liquid at minus 196. And that is to say that the what? Fill in the blanks. That's to say that, no, read further.
Melting.
That's to say that,
Condensation.
no, read. The boiling point of liquid nitrogen, so we're going to bring it out, liquid nitrogen, look. Now what you see is not liquid nitrogen, what you see there, the smoke, is what we call, this is liquid nitrogen, which is actually a very cold liquid. Okay? This is a very cold liquid, and it is really very cold, close to almost 200 degrees Celsius, minus 200. The first question that the student normally asks is, will it crack the glass? The answer is no, because this is made of pyrex, and pyrex has the ability to expand very little when there is extreme temperature. So if it expands very little, that means that when it's very cold on the inside layer will contract very little, so that it will not pull the outside layer in and crack it. Alright? So we call in physics, there's a very low expansivity. And this is liquid nitrogen, which is if I put it over here, can you see that it can actually drops there? That's cool, no? Let's pour it over here. Okay. Let's pour it over here.
So what happened with that?
Can you see here it's moving all over the place.
Is that liquid?
Yeah, that's liquid nitrogen floating around.
Touching
But
water is like,
soon enough it will vaporize. This is a PL balloon. Wow, this balloon has got PL. This was printed a long time ago, 5 years ago, when we were having our 10th anniversary for the tuition center. PL balloon, PL education center. Now this balloon, what we're going to do is we are going to pour liquid nitrogen over this, and let's see what will happen when we pour liquid nitrogen. Now we start playing, or I start playing around with liquid nitrogen 5 years ago, and I will actually sketch stiff liquid nitrogen. The punch there, sketch stiff, and let's see how this becomes.
oh crap, that's sick.
Usually we fill this with helium. Helium normally will rise, right? But when we pour liquid nitrogen over this, the helium will shrink, the helium balloon will shrink, and it will not float. And when it comes back again, then you will rise up like that. We have that in the YouTube. If you go and find and put it in the YouTube, you type in Peter SP Lim, which you will find, and then the balloon is now flexible. It's flexible again now. So you can see that coldness can change the state of things, what is flexible now becomes inflexible. And you will find that when you pour liquid nitrogen over this, the molecules of air inside here will move slower and closer. Right? And when they move slower and closer, it will begin to shrink. Okay? Now, we are going to crack this balloon. This is the only one that I have. Let's crack this balloon. Let's hook this. Then we will try to put liquid nitrogen over this. Okay? So what we want to do, this is flexible. Huh? So we put liquid nitrogen over this, and let's see what happens. I mentioned this as what you see here is actually water vapor. Our air is very humid. Even inside here, the humidity can reach something like 60 to 70%. Outside will be about 80 or 90%. And now I take this one out and look.
Shit, glass.
Yeah.
It's almost like glass.
Yeah. It goes into pieces, you know. And of course, when it thaws back, it becomes flexible again. You see?
It becomes really rigid now.
Becomes, yeah, just now it was really rigid. And I remember